All right, so I'm going to record a thing on databases. Before you begin working with databases, you should have some idea of what they look like. This is PG Admin, which is the front-end client for Postgres, the database we'll use for our second database. So notice over here we have a browser for the objects, and it has servers, and right now I have two servers. I have two versions of Postgres in there. This window right now is empty, but I'm going to open up Postgres. I'm going to have to give it my password. And I'm going to look at the server 11 there. So it opens up and it shows the objects that belong to the databases. I have two databases on this server. I have a Community Assist PG and Postgres, which is a system database, basically. We have loggings and table spaces. So this is our Community Assist database. Databases consist of a lot of different objects. The ANSI and PostgreSQL catalogs in here are the system databases that keep track of all the different systems, all the different meta information about the database. I'm going to open a query tool. The query tool is a tool that lets you run SQL statements. So just to show you real quickly a system one, I'm going to do select name from system or from information schema tables where schema, I'm not sure that's correct, schema equals public. Let's see if that works. This is SQL, by the way. This is the language that all databases use, regardless of whether they're Oracle or MySQL or Postgres or SQL Server. They all use this. The little lightning bolt up here runs it, and it doesn't. I think it's table name. Let's try that. I'm doing this without looking, so. And then I didn't select it all. So it's not schema. Let's just run it from here, and then I'll fix it. So I'm going to change this to an asterisk. This isn't the important thing, by the way. This is just to show you how. And again, I need to not do the where clause. Schema name, I bet. Table schema. So let's do the last thing. Where table schema equals public, and we'll just get, instead of asterisk, we'll do table name. So this is the only one I'm going to do for the meta information. You might notice there's select the column that you're looking for, or columns from. This is basically, it's telling us we want that catalog, we want the table in there, and we want that where the table schema sets the criteria, and we want only the ones that list public. So I am going to do that, and it'll show us the names of all the tables in our database. The tables here are listed under schemas, public tables, and you can see all the tables that will match right here what this, what the query gave us. I'm going to show you a little bit more. I'm going to show you what the database data looks like. So I'm going to select star from person. Person is a table. See? The asterisk means select everything. If you look at the person over here, you can look at the columns. So we've got a person key, last name, first name, email, phone, and a date added. So I'm going to do that, and you will see that a table is basically a series of columns and then rows of data underneath it. The numbers here are the primary keys. They are just numbers. They're just doing that. You have their last name, first name, email, phone, and the date that they were added. Okay, so that's fairly obvious, and it can go on, for quite a while. Notice I don't have their addresses here. Their addresses, I'm going to do this. Select star from person address. Because some of the people in this database, and this is a database that's basically a fictional charity that gives people money when they're in need. So, but some of the people have more than one address. So notice we have the address key, and then we have the person key, right? So basically, the only relation to the person table is by this person key. That's how relational databases work. One key relates to the other. So the person 1 here has 3 different addresses, right? And if you wanted to know who person 1 is, we could up here, I would say where person key equals 1, and we'll find that it's Lynn Kindle that has 3 addresses listed. I'll show you later how to do a join. Let's look at another table. I'm going to select star from employee. When I do this, you'll see that there's no employee names. There's just an employee key and then a person key. So all it's doing, it's associating the employee, giving them a key, and associating them with the person. It also doesn't say what their position is. So if I do select star from position, I think it's job position. All right, job position. Did I spell position wrong? Oh, I did JBO instead of JOB. For some reason, this doesn't always type. All right, so when I run that, you'll see that there's the names of the positions, and each position has a key. Now, in order to see which employees have that position, I need to do select star from employee position. All right, and when I run this one, and you might notice when I select it, it only runs that one, that we have the positions of, and the employee key and the position key, and the employee position key, and then the date that it's assigned. So the thing about relational databases is a lot of these tables are not humanly all that readable. The keys relate things, but you often end up with tables that are just keys, and that doesn't make a lot of sense to just read it off the fly. It is possible. I'm going to show you. So I'm going to do select, let's do last name, person last name, person first name, position name, All right, and we're going to do this from person, and we're going to join with employee. So we're going to combine tables here. I have to say how they join. So they join on person key. I'm going to also join on employee position. And this will use employee key. And then I'm going to join with position, job position, using position key. So if I bring all of these together, except you have to type it right. SQL is a nice programming language. It's pretty readable, but it's still everything has to be correct. So now notice I can see the employees and I can see the positions. So I got their first name, last name, and their position. We could add other fields to that if we wanted. So the point of this is just to show you what a table looks like. Let's look at donation real quickly, and then we'll probably call this good. Select star from donation. So you see we have the donation key, the person key, the amount of the donation, the date of the donation, and every donor gets a series of numbers basically to validate their donation if they want to check back. Okay, so database, again, it's basically consists of tables, and those tables are related to each other by way of keys. Tables are not always humanly readable, and that doesn't matter. Right? What matters is that the data is there, and the data should never be repeated. The other thing to notice, this is SQL. We will play with it some. There are other ways you could do things. Like I could right-click on, let's do person, I guess. And you can view data, and let's do all rows, and it will show you all the rows. It actually, notice it writes this same thing up above that I wrote pretty much. So it is possible to view the data without using SQL, but SQL is by far the most efficient way to get it out. All right, there are other things about the database and that we will look at. Like a table, as I said, is basically a grid with columns, right? Each column has a name, each column has a data type, and then underneath that column there are rows. Each row has its own individual key that identifies it as a unique row. I hope this helps. I think that's all I'm going to do for this video.